Welcome to the PilotFish eiConsole for ACORD LAH demo. Today we'll be walking through using the eiConsole, shown here, to build an ACORD 103 new business submission interface. When we first start the eiConsole, we're shown this route file management screen. This will show us our currently selected working directory, or project folder, as well as any interfaces or routes actually configured within there. Of course, we can always get started by building a new interface by browsing our PilotFish Interface Exchange. The PilotFish Interface Exchange is an interface repository where you can search for and download pre-configured interfaces and templates. This is a great way to get started building a new interface. We can browse through a template, download it, and just tweak and modify it to go. We'll continue a demo by just walking through this pre-configured interface, this app to new business. We'll open this up and get our main eiConsole screen shown here. Each of these 7 stages you see represented by the columns in this table are one of the steps in our assembly line approach to building interfaces. Each row on the left-hand side, though we only have a single row, and each row on the right-hand side represents source systems and target systems. Source systems are going to be places we're receiving data from, and target place systems are places we're sending data to. We'll start with our first stage and move left to right, configuring and describing each stage as we go. Our first stage is a source system. This is just a place to provide a name and, optionally, an icon and metadata to best describe what it is we're connecting to. This, along with the target system, is going to act as documentation, so we can just glance at an interface and get a feel for what it's doing. We'll then proceed to our listener. The role of the listener is to decide how we'll actually connect to that source system. You do that by choosing one of these listeners in this drop-down or a dialog here. If you can think of a way to send or receive data, we probably have a listener built in. And if we don't, any point you see drop-downs or dialogues like this are points of extension, so we can write our own modules in Java or .NET. Once you've selected a listener type, you'll just need to configure it down here in this configuration tabs and various fields. For this RESTful web service, we're just going to provide the service name and the various list of resources that we actually support. Each source system can then have a number of processors associated with it. Processors are low-level operations on data, things like decryption, decompression, and character conversion, allowing us to modify or slightly work with the data before it actually proceeds to the further stages. Each source system then has a source transform associated with it. The job of the source system is to take whatever that particular source system gave us and convert it to a canonical representation of the data we want to process in this interface. We do this in 2 steps. The first step is a transformation module to take any non-XML format and convert it to XML. This could be anything like an ACORD AL3, CSV, delimited and fixed width files like COBOL copybooks or other formats, JSON, Microsoft Excel, name value pairs, or we could just accept XML as is. Here we've chosen the JSON transformer to take JSON we received from a web service and convert it to XML. The next step of our source transformation is a logical transformation built using our Datamapper. We'll come back to this because the transformation for our target is a little bit more interesting. After we've completed our source transform stage, we'll continue on to the routing stage here in the center. Now the jump of the routing stage in the middle is twofold. First, in the Routing Rules tab, we can configure which target systems a given message is going to go to. Now we only have one target here, so we've chosen all targets, but we could set up arbitrarily complex expressions, routing on the contents or metadata about a message, so that we only go to particular targets if a message has. We can also use this stage to configure transaction monitors. These are going to be our proactive error notification and alerts if anything goes wrong or unusual in the processing of our interface. When our message reaches one of the targets, we first go through a target transformation. Like the source transformation, this happens in 2 steps. A logical transformation over here using our Datamapper, and an optional transformation module on the right. We'll open up our Datamapper now and take a look at the mapping we have to go from a canonical format to an ACORD 103. Here we have the Datamapper. This is our 3-pane mapping tool we use to build all of our logical transformations. On the left-hand side, we've loaded in our source format. In this case, it's a canonical representing a new business submission. On the right-hand side, we've loaded in our target system. Here we've read the actual ACORD TXLife definition. And as we browse through these different fields and elements, we'll see the ACORD descriptions and definitions are inline in the tool, as well as any values like ACORD type codes. So we can search through and browse those, and that'll allow us to work with ACORD without needing to refer to external documentation. In the center, we have a tree representing our actual mapping logic. We'll build our mapping by dragging and dropping from our source and target formats into this tree here in the center. And we can augment those mappings with these structures up here. Here we can find rules for flow control, like loops and conditions, as well as the ability to interact with XPath and XSLT functions, callouts, and anything else we need to augment that mapping as we build it out. Working with the Datamapper is basically just drag and drop. So we can find particular elements in here. For example, we could take this transaction execution date and delete it. If we wanted to remap it, we could simply go over here on the right. We'll notice that, unlike the other fields, it doesn't have a check mark, so we know it is and isn't used just by looking. We'll drag and drop this element onto its parent, and then from here, we have several ways of populating it. We can use this palette up here, so for example, we could do a callout to grab the current date, or we could just grab it from our source system and drag and drop that onto that element. So we'll build our entire mapping just by doing drag and dropping. There's no scripting or coding anywhere in the tool unless you just want to do it. Now underneath, the mapping produces W3C compliant XSLT. XSLT is a web standard transformation language. It's been around since 1999, and we do have a fully featured editor here. So if you wanted to make changes, we could add our own elements and attributes within here, and any elements or attributes you added would show up in the mapping view and vice versa. Now in addition to being able to build out your mapping in the Datamapper, we also have fully featured testing. So you can give it a sample file, push a button, and see the output of the transformation. We have a debugger if you'd like to do this step by step and see exactly what's happening at each stage of your transformation. And in terms of those source and target formats, we have a variety of ways of reading those in. Using our format readers, we can read in the ACORD Life, PNC, and RLC formats directly, including not only the schema files, but the metadata files including type code definitions and other documentation information. We can read in from sample CSV files, web services, or even databases directly. And for all of these different formats, reading and using these different format readers is going to provide the same level of information that we see for ACORD here. Also for ACORD, we have built-in recognition of those type codes. When we're looking at fields like trans type, we can select those from an enumerated list. We have a tabular mapping tool to allow us to automatically and easily map between codes from one system and another. There are also built-in collaboration tools. We can go to any given field, go to our Notes tab here, and add our own notes. The notes allow us to collaborate. They allow multiple users to share documentation and information while they're working the same mapping, as well as the ability to add comments within here in the center. That's our Datamapper at a 10,000 foot view. And again, we're going to use this for all of our logical transformations. So while we're using this to map a canonical to an ACORD 103, we could also use this to map from ACORD to a database, from some flat file to a completely different file format. Really, whatever you want. It's all going to be done in the same tool here. Now that we've completed our mapping, we'll close our Datamapper. Now at this point, we received our message from our listener. We've transformed it to our canonical message. For this target, we've transformed it from the canonical to the ACORD 103. Next, we'll continue on to our transport step. Now the transport, like the listener, has processors. So if we needed to encrypt or compress data before we sent it out, we can do that here. And the transports, like the listeners, have a myriad ways of sending data out. If you can think of a way to send or receive data, there's probably a transport for it. Here we're going to send it off to some HTTP endpoint. Now after you've gone through left to right and you followed our assembly line approach to building your interface, you can do testing from right within the console. Simply go up to Mode, Testing Mode, and pick where you want to start your test. Now from within testing mode, this first green arrow is going to represent where our test is currently set up to start. The blue arrows are all the places a message could go, and these question marks just mean that for this test, nothing has happened yet. Now we can start our test at our listeners, we can also load in sample files, and we can save and load testing sessions from before. So we can build a battery of unit tests that we can apply later. Here we're going to start a test at the source transform using this JSON sample message. We'll go ahead and hit execute test, and we'll see our message move left to right. As each stage successfully completes, we'll get green check marks, and for our failures, we'll get a red X. And now we can follow our data along through the different stages. We can see the XML representation of our JSON message after we've transformed it. We can see the results of our transformation to our canonical, which for our test case here is empty. And when we go on to our target transform, we can see the results of the ACORD 103, and then finally, we can see why our message failed at the transport, which in this case, we don't have access to this server. So what we'd need to do is go back to editing mode, make any quick changes, and swap between editing and testing until everything is working exactly how we'd like. Then we'll return to that very first screen, route file management, and decide if we want to deploy our interface. Now there are a number of ways to deploy our interface, but the easiest is to simply go into server view, provide connectivity information to your EI platform, hit connect, and then simply drag and drop our interface from the top to the bottom down here. We can also share our interface out on that same PilotFish interface exchange we potentially started with, as well as using our dashboard or a number of other methods to deploy and ultimately maintain that interface in production. And that's it. A tool to enable you to connect really any system to any other system, regardless of protocol or format, but some special emphasis, features, and support for the ACORD LAH and PNC standards.